Hello everyone, nice to see you again. Today's training is about three control modes of self-drive: position mode, speed mode, and torque mode. There is a lot of content in today's lesson, so I will speak quickly. And by the way, today I also have a lucky draw. The gift also a Panda doll, a notebook, and a pen. But in this time, I will draw this gift one time to give one person. So to see who is the lucky guy. Okay. Okay, let's begin. First part is position mode. First part is position mode. We use this mode most frequently. Okay, it's the lucky draw. It's 3 gifts for one person. We use this mode. We use this position mode frequently, and all 3 modes I will talk them as introduced. And all 3 modes I will talk them as introduced, command source, and commonly used DRDO 3 parts. Now let me introduce the position control. We use this mode to receive position control through PLC pass output. Drive will receive the pulse and rotate the command. Drive will receive the pulse and rotate the command distance. The distance depends on the pulse number and the speed depends on pulse frequency. We can use position instruction to control servo to move. Like this picture. DRVI instruction is relative move instruction. It's supposed to control these four parameters. These instructions mean the motor will move once, will move 10,000 pulse. 10,000 pulse command distance and this instruction means the motor will move 10,000 pulse command distance and its speed is 2,000 pulse per second, which means the distance need motor to move 5 seconds. Okay, next. This is the control mode, classic 3-loop control. Position control mainly affects the position loop. The loop control is difficult. It's difficult to understand. Just note it. Second part is position command source. These parameters P0 and 01 uses to set control mode. You can see there are six modes: position control, speed control, torque control, position and speed mixed and 3 mixed control. The mixed control means we can select 2 control modes among three control modes above to mix. For example, the force, position and speed mixed control. This means the servo will work in position mode as default. If an input signal send to drive will change the control mode to speed mode. So we can use DI terminal to change control mode between position and speed. And here is position command source. E01 and 06. You can see drive support two mode, pass command and internal command. You need PLC to send pass when you set the parameters to 0. If you set it to 1, you need to set the target position and the target speed in servo, and we control it through sending DI signal without sending pass. But please note, if If you want to use internal control function, the firmware should meet these requirements. Next. This one. P00 and 04 used to change direction. Easy to understand. Next. P0 and 20 used to set position path type. We usually use the default setting 0, and I will mainly introduce it. This means that one terminal to send the path, and one terminal to send the direction signal. This two video, you can see. For the video 1, Y0 send path, and Y1 is the direction signal. And for second video, same configuration. So the direction of movement of the motors in video 1 and video 2 is opposite. Okay, here is the waveform about the moving. You can see they are opposite. This part introduce the relationship between motor position and path. For P0 and 16, it means how many paths sent will make the motor rotate one circle. The default value is 10,000, means 10,000 paths per circle. And for these two parameters, you should set them together. And if you want to use these two parameters, you must set P0 and 16 to 0 first. And then you can use these two. And then you can use these two methods to set the path equal to 1 micrometers, according to this. This part is the final part of position mode, commonly used DI. First, for DI, we have many DI inputs. These two parts is commonly used in DI. There is an introduction behind each. And if you want to see more DI function, you can click this link to see in detail. And this is the table of default DI pin defined. Pin Okay, wait a minute. Oh, okay. This is pin 9 corresponds to DI1 and so on. And This is DI setting. It's easy to understanding. It's easy to understand. The SC2 introduced this in detail. But I will introduce the P6 and 04. And I will introduce P6 and 04 in detail. The virtual input means you can use modbus communication to change the DI signal. In group 13, let me show the SC2. Here, you can see in certain groups, there are virtual DI input, and from DI 1 to 8. We can use this modbus address, this automatic address to set signal. Set the turn is on or off. And when you set use hardware input means you cannot use the virtual input to send signal, and then its DO function is same as DI. It's two parts commonly used. And the pin define, it's also like DI. And the DO setting, also easy to understand. Now, let me introduce the second part, speed control. This control mode many use in the application that has high requirement about speed control. In this mode, we can use our motor. We can make our motor run in the speed we wanted. And there are two methods to control the speed. One is analog input, and the second way is use speed command to control. Also, a 3-loop control mode. We can see this control method is affect the speed loop. Different with position control. Here is a simple wiring picture. You can see here are 3 terminals, DI 2, 3, and 4, correspond to internal speed selection 1, 2, and 3. Because our drive supports up to 8 segments speed, it needs 3 terminals to select which speed the motor runs. 2 plus 2 plus 2 equal to 8. Okay. Second part, internal speed source as the position control. Same as the position control. This code P0 and 01 need to be set to 2. Okay. And you can select which method above to control in P1 and 1. But please note VD2F doesn't support the analog input. So the VD2F can only support the internal command control. And here is about the acceleration and the deceleration, about the velocity. We use these two parameters to set them. But be careful that the parameters doesn't mean the time the motor to the target speed, but mean the time the motor to 1000 RPM speed from 0. And the P1 and 4 the acceleration time is same. So you can see these two formulas to calculate the actual acceleration time. The speed instruction divide 1000 and plus acceleration time and plus this parameter. And in these pictures, you can easier to understand. We set these two parameters to 50 for first picture. Motor spent 50 milliseconds to achieve the target speed. And for the second picture, motor spent 150 milliseconds to target speed 3000 RPM and 1000 RPM. And their acceleration is same. The purple curve is torque. In this situation, no load, only accelerate. In this situation, you can think this as acceleration. And there are two different methods about shutdown. Set the speed as 0. Directly to shut down. The speed of motor will deceleration in the setting. In the setting value. These parameters P1 and 4. And the second way is directly disable the motor to stop, and obviously it spend more time to stop. And here is another way to shut down. It is deceleration stop. First, how to use these methods? First, set the DI function to 8. Is stop mode. Then set these parameters P1 and 4 shutdown declaration time. Later, after trigger DI, after trigger DI receive the signal emergency shutdown. Motor will emergency stop and degrade to 0 in these parameters in this declaration, not the P1 and 4 parameters. You can see the picture here. And then here's the limit parameters to keep people and machine safe. And then they are described in detail below. Take a look. Oh, and what need to notice, and what need to note is that P1 and 11. When the speed exceeds its limit, only an arm will display, not an arrow. The motor will keep moving. So if you want the motor stop when the speed exceeds limit, you need to set these parameters P1 and 10, but not these parameters. Here is about how to use internal speed source. We can use panel Modbus and SC2 to set. However, we usually use this function. We usually use this function through Modbus because the panel setting is so inconvenient, and the SC2 many use in debugging. It is impossible to use SC2 when machine working. Okay, the final parts of speed control. Hello. Finally, the final parts of speed control, commonly used the IDO, same as position control mode. We commonly use this parts, and click this link for detail. As same as the position mode above, and these parameters, speed threshold. This means when the speed of motor exceed the value we set, the DO will send on signal, and when And when the motor actual speed lower than the value, the drive will send off signal. And this is the opposite function code, just like this above. And this is speed consistent output. This means for example, when we set the P519 as P516 as 100, and P517 as 10. This means when actual speed achieve the target speed 100. Between 19 and 110, the drive also think the speed is reached. Why we need these parameters? Because in actual situations, motor it is impossible that motor keeping a precise constant speed. If we set these parameters to 0, the reach signal will change frequently. So this will influence our judgment. We need to set these parameters. Okay. The final part, torque control. Please be patient. Today's content is much. Motor will output consist torque by using this mode. So we commonly use this in winding machine, swarm machine, unwinding machine, and so on. Just like the speed control, there are also two methods to control: analog input and internal torque command. Three loops control mode again, and the torque control mode affect the current loop because of this formula. The torque equal number pass current. Okay, next. This is a rewinding case. Because we need the machine to keep same force during working, the thickness of roll will change. If we use other modes, we cannot achieve achieve the function, achieve this function, because we need to keep paper tight. Okay, second part. Internal torque source. Same as speed, position. Should select 3 to choose torque mode, and also VD2F don't support analog input. And the torque settings E1 and 1. Its unit is 0.1%, and be careful. These parameters, these monitor parameters, its unit is its percent. And for these parameters, it means that percentage of the motor torque. For example, if the motor's rated torque is 10 newt plus meters, and we set its parameters to 500, then the motor will move in 50% torque. So it is 5 newts plus meters. And this parameters is used to read the real-time torque of motor. Also like speed control, there are limit parameters. We can use internal instruction to set the limit, or use analog input. Usually we use in instruction. Analog input is rarely used. And after we set P1 and 14, we need to set these 2 parameters: forward and reverse torque limit, and the unit is also 0.1%. And before I introduce this, there is a basic formula, Newton formula. I think everybody should know it. F equal to m plus a. Focus equal to m plus a. Combine to this picture. When torque is bigger than load torque, so the focus is positive, and the accelerations and the motor will accelerate. And then when motor torque equal to load torque, the focus equal to 0. So the motor run in a uniform speed. And last, when motor torque is smaller than load torque, motor will acceleration. And this function used to send a signal to tell the motor to tell the drive that the motor torque achieved the limit. Okay, and this part is the speed limit under torque control. Why we need this? Why we need this in torque control? Because the formula, because the Newton formula. If suddenly the load disappear, there is no load, and you set the uniform torque. The accelerations will improve suddenly, and then the speed will keep increasing very fast. So this is dangerous. We need these parameters. Also have two ways to set internal instruction and analog input, same as torque limit set. Also have two parameters to set forward and reverse speed limit on the torque mode. Okay, I can see you. Wait a minute. Also have two parameters to set forward and reverse speed limit. Okay, these parameters can make torque stable, but do not set it too big. This will reduce the motor response. Okay, the final parts. Commonly used the ideal of torque function. Training wheel, and so on. Also easy to understand, like speed and position control mode. And I will introduce this in detail. How to use these two parameters. Like the parameters I talk in speed above. When we set P5 and 20 to 100 and P5 and 21 to 10. By the way, the unite is percent. Unite is 1%. When we set the parameters to this value, when we set these two parameters to this value, it means when actual torque achieve the torque between 19 and between 19 and 110, the drive will also think the torque is reached. because in actual situation, motor keeping a process uniform torque is impossible. If we set P5 and 21 to 0, you can see in this picture the green curve is torque reach signal. When we set this parameter to 0, you can see the torque reach signal changed frequency. It will affect our judgment. Then, if we set it to 3, the torque reach signal will not change as the left one. Okay, today's class is over, and finally, we will give you gift, and a doll, and a notebook, and a pen to 1%. Okay, I can see you in comment, and oh, the pass in internal mode. I can stop the mode. Is there? Okay. Let's lucky draw first. Let's have a lucky draw first. Sure. How many body? Pass. Yeah. Okay. Anybody else? We have 3 gifts. Okay. If there's no one, I will click. Okay. Who's the lucky guy? Wow. Congratulations. You will get this 3 gift. We will send you later. Okay. And the past question. I can stop the motor X from hand. Motor do not generate torque. When you stop the motor, I think motor will keep torque. Even when motor stop. Okay, let me see. Okay. Let me talk this later. Okay, today's training is over. Thank you for hearing. I will end the stream.